Example 2. Write the second order Taylor formula for f of x equals log of 1 plus x, centered at x equals 0, and calculate its estimation for log 1.2. Okay, so we want the second order Taylor polynomial. So I'm going to write this as t2 of x. Okay, and that's going to be based on the derivative. So we have for n equals 0, we're going to have log of 1 plus x. Okay, when we evaluate it at the center, so center being 0, log 1 is going to be 0. Okay, so our an is going to be 0 here. Our first derivative is going to be 1 over 1 plus x. Centered at 0 is going to be 1. It's going to be 1 over 1 factorial, which is equal to 1. Our second derivative is going to be negative 1 over 1 plus x to the power 2. And when we evaluate at 0, I end up with negative 1. So I end up with negative 1 over 2 factorial, which is equal to negative 1 over 2. And then the third, this is going to be our estimation term, or our remainder term, 1 plus x cubed. Okay, so I'm just going to highlight that this is going to be my r of x term here. So this is our second degree Taylor polynomial is going to look like this. It's going to be 0 plus 1 to the power of x to the power 1 minus 1/2 x to the power of 2. Okay, and then it's going to be plus, in this case it's going to be r of 2 of x. Okay, so our cubic term is going to give us our remainder term. So when we work this out, this is going to be approximately at x equals, in this case it's going to be t of t2 of 0.2 to give us the log of 1.2. X needs to be 0.2. So we end up with 0 plus 0.2 minus, in this case it's going to be 1/2 0.2 squared, which is going to be 0.02. Okay, and so this is approximately going to be equal to 0.18. Now we can, if we compare this to the actual value, it's going to be 0.18232. Okay, so we want the expression for the remainder term. The remainder term is going to look like this. R of 2 is going to be equal to our derivative, 2 over 1 plus b to the power of 3. Okay, and b is, again, is a bounded value between 0 and 0.2 over 3 factorial and x minus 0 to the power of 3. So this is what the expression for remainder term is going to look like. So we want to maximize the error. So what we need to do is find the maximum value, m, and we know that's going to be less than or equal to. When we take a look at the maximum value, we're looking at maximizing this term here. And the b value that will maximize that term is going to be when b is equal to 0. Okay, so the smaller the denominator is, the bigger the term is going to be. So when we put this in, we're going to plug in b is equal to 0. So 2 over 1 plus 0 cubed, that's going to be equal to 2. Okay, so that m value of 2 is going to be give us the maximum error. So when we want to find the maximum error, our max error is going to be based on that m value of 2. It's going to be less than or equal to 2 over 3 factorial 0.2 to the power of 3. And when we work that out, we end up with 0.2 to the power of 3 times 2 divided by 3 factorial, and I get a value of 0.0026 repeating. So I'm going to round that to 27. Okay, so if we take a look at the actual value is equal to 0.18232, and you can see that our value of 0.18 is plus 0.0027 is within the bounds of our actual value.